Welcome to our comprehensive guide on Jest interview questions. Jest is a powerful JavaScript testing framework that has become essential for modern web development. In this series, you will master the core concepts that every developer needs to know about Jest, including unit testing, mocking, snapshots, coverage reporting, and test automation. These topics are frequently asked in technical interviews and are fundamental to writing reliable JavaScript applications. Whether you are preparing for an interview or looking to strengthen your testing skills, this series will provide you with the knowledge and confidence you need to succeed. Jest is a JavaScript testing framework developed by Meta, formerly known as Facebook. It was created to provide developers with a delightful testing experience that requires zero configuration for most JavaScript projects. Jest comes with everything you need out of the box: a built-in test runner that executes your tests, powerful snapshot testing capabilities that capture component output, comprehensive mocking features for isolating code, detailed code coverage, reports to track your testing progress, and parallel test execution for faster results. The framework is designed to work seamlessly with React applications, but is versatile enough to test any JavaScript codebase, making it a popular choice among developers worldwide. Setting up Jest is straightforward and can be done in just a few simple steps. First, initialize your npm project by running npm init-y in your terminal. This creates a package.json file for your project. Next, install Jest as a development dependency using npm install-save-dev-jest. This ensures Jest is only included in your development environment, not in production. After installation, you need to add a test script to your package.json file. In the scripts section, add test:*jest. This allows you to run your tests using npm test. Finally, verify your installation by running npx just version to check that Jest was installed correctly. Once these steps are complete, you are ready to start writing and running tests. Let's create your first Jest test by testing a simple function. Start by creating a function file called sum.js that exports a basic addition function. This function takes two parameters, a and b, and returns their sum using the plus operator. The function is exported using module.exports equals sum. Next, create a test file called sum.test.js. Import the sum function using const sum equals require./sum. Then write your test using the test function, which takes a description string and a callback function. Inside the test, use expect with the sum function call, passing 1 and 2 as arguments, followed by to be with the expected result of 3. This test verifies that 1 plus 2 equals 3, demonstrating the basic structure of a Jest test. Jest provides a comprehensive set of matchers for making assertions in your tests. The most commonly used matcher is to be, which checks for exact equality using the triple equals operator. For deep equality comparisons of objects and arrays, use to equal. When testing for null values specifically, use to be null. For checking if a value is truthy, such as true, non-zero numbers, or non-empty strings, use to be truthy. The to contain matcher is useful for checking if an array includes a specific element or if a string contains a substring. Here are some examples. Expect 2 plus 2 to be 4 checks exact equality. Expect an object with name John to equal another object with name John compares object contents. Expect an array containing 1, 2, 3 to contain 2 verifies array membership. These matchers form the foundation of test assertions in Jest. Mocking is a powerful feature in Jest that allows you to replace functions with mock implementations for testing purposes. The jest.fn function creates a mock function that you can control and inspect. You can set return values using mock return value, which makes the mock function return a specific value when called. For more complex scenarios, use mock implementation to provide custom logic for your mock function. Jest also provides matchers to verify how mock functions were called. The to have been called matcher checks if a mock function was invoked, while to have been called times verifies the exact number of calls. Here's a practical example. Create a mock function using const mockfn equals just.fn, set its return value with mockfn.mock return value 42. Call the function and expect it to return 42. Finally, verify it was called exactly once using expect mockfn dot to have been called times 1. Testing asynchronous code is crucial in modern JavaScript applications, and Jest provides several methods to handle this effectively. The most modern approach uses async and await keywords. Mark your test function as async and use await when calling asynchronous functions. For promise-based testing, you can return a promise from your test function, and Jest will wait for it to resolve or reject. When working with callback-based asynchronous code, use the done parameter in your test function and call done when the asynchronous operation completes. Jest also provides special matchers for promises, resolves, and rejects. These allow you to test promise outcomes directly. Here's an example of async testing. Create an async test that awaits a fetch data function call, then expects the return data to equal a specific value. For promise testing, return expect async function call dot resolves dot to be expected value. These patterns ensure your asynchronous code is properly tested. Snapshot testing is one of Jest's most distinctive features, designed to capture the rendered output of components and detect unexpected changes over time. When you run a snapshot test for the first time, Jest creates a snapshot file that stores the component's output. On subsequent test runs, Jest compares the current output with the stored snapshot. If they match, the test passes. If there are differences, the test fails, alerting you to potential regressions. Snapshot files are stored in a snapshots folder and have a .snap extension. When you intentionally change a component and want to update the snapshot, use the -u flag when running tests. Snapshot testing is particularly effective for catching unintended changes in user interface components. Here's how it works. Render a component, such as a button with text "click me," then use expect component dot to match snapshot. This creates a snapshot of the component's structure and content for future comparisons. Code coverage reporting in Jest helps you understand how much of your code is being tested. Jest measures 4 key metrics. Statement coverage shows the percentage of executed statements. Branch coverage tracks how many code branches were taken during testing. Function coverage indicates which functions were called, and line coverage measures how many lines of code were executed. To generate coverage reports, run npm test with the -- coverage flag or use Jest -- coverage directly. Jest can also be configured to collect coverage from specific files using the collect coverage from option followed by a file pattern. Coverage reports help identify untested parts of your codebase and ensure comprehensive test coverage. The reports are generated in multiple formats, including a detailed HTML report that you can view in your browser. Maintaining high code coverage is important for code quality, though remember that 100% coverage doesn't guarantee perfect testing. Focus on testing meaningful scenarios and edge cases. Following best practices ensures your Jest tests are effective, maintainable, and reliable. Always use the AAA pattern. Arrange your test data and setup, act by calling the function or method being tested, and assert by checking the results. Write descriptive test names that clearly explain what is being tested and what the expected outcome should be. Keep tests isolated and independent so they don't affect each other and can run in any order. Test edge cases and error conditions, not just the happy path scenarios. Follow test-driven development by making tests fail first, then writing code to make them pass. Avoid testing implementation details and focus on testing behavior instead. Don't overuse mocks and stubs, as they can make tests brittle and less meaningful. Always handle asynchronous code properly using async await or proper promise handling. Never share state between tests, as this creates unpredictable results. Avoid complex test setup logic that makes tests hard to understand and maintain. Following these practices will help you write robust, maintainable test suites that provide real value to your development process.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.